On July 23, 1999, the Space Shuttle Columbia launched carrying the Chandra X-ray Observatory as a member of the Great Observatories program at NASA. This program was a triumph in NASA's history that may not be as well known as the Apollo moonshots, but it greatly increased our understanding of the universe around us in a way that was previously very difficult to do at any decent resolution. The four great observatories in the program were Chandra for X-ray astronomy, Compton for gamma rays and a little overlap into hard X-rays, Hubble for visible light, and the Spitzer Space Telescope for infrared. Spitzer was launched in 2003 on a Delta II rocket and depleted its supply of liquid helium coolant in 2009, which restricted its abilities and was finally taken out of service and put into safe mode in 2020. Its successor is the James Webb Space Telescope, which we now use for top-notch infrared astronomy. The Compton Gamma Ray Observatory, which had multiple telescopes, was launched in 1991 on the shuttle Atlantis, and functioned until the year 2000 when it was deorbited after a gyroscope failure, exceeding its designed lifetime. The gyroscope failure on Compton was actually NASA's first intentional deorbiting of a satellite, and the telescope actually was still functional. The problem is that if another gyroscope failed, then deorbiting it would have been almost impossible, meaning it posed a risk to people on the ground. So NASA ultimately opted to have it re-enter. Compton's successors are many, including ESA's Integral spacecraft, NASA's Swift mission, and several others that are all in service. The Hubble Space Telescope is the most famous of the four and needs no introduction. Unlike Spitzer and Compton, it's still functional and continues to make valuable observations and will do so probably for years yet, though it's showing its age. But it's safe in that it remains funded. Chandra is also functioning and continuing science operations, but it is most definitely not safe as far as funding. More on that in a bit. Chandra is nothing short of astonishing. It outdid any previous X-ray telescopes by a factor of 100 as far as faintness, and actually is a technological marvel put up against anything before it. X-rays are very difficult to focus and observe, so the mirror of Chandra has an unusually high angular resolution. Moreover, to observe X-rays at all, you have to get high up or go to space because Earth's atmosphere absorbs X-rays and little makes it to the ground. So Earth-based telescopes are off the table, though limited high-altitude research can be done with balloons and other means. Chandra is in orbit, however, and in an ideal position to study the X-ray part of the electromagnetic spectrum of the universe. Named after the great astrophysicist Subrahmanyan Chandrasekhar, the idea began in 1976 with a proposal to NASA for an X-ray telescope of this nature. The idea was pursued, but very slowly, and was entirely redesigned in 1992 to a sort of stripped-down version of the original idea to cut costs. The spacecraft was designed for an elliptical orbit that takes it about a third of the way to the Moon to keep it mostly out of Earth's radiation belts. And because of that, it could not be designed to be serviced as Hubble was. Hubble would have never worked without its servicing missions. The very first one was to fix an optical mistake called spherical aberration, which results from the outer edges of a telescope mirror being too flat, causing different areas of the mirror to come to focus at different lengths. In short, the contractor ground the mirror incorrectly due to flawed testing equipment, and Hubble had blurry vision. Chandra, however, worked perfectly, and after all these years, remember it's been up there since 1999, amazingly it's still functioning very well, even without the ability to service it. Especially amazing is that it was only designed to last for 5 years, and then it was extended and continues. And estimates on its remaining fuel is that it still has as much as a decade left. That's if it doesn't get canceled and shut down, and that's set to happen. The time frame of shutdown will be 2025 and 2026. Drastic budget cuts in 2025 will see it lose about half the staff, and severely curtail any observations that can be done. In 2026, there will be more cuts, effectively ending the mission. NASA obviously doesn't want to do this, but maintaining a 24-year-old telescope on a budget with a ton of other programs going, amid a general budget cut, including new ones, is ultimately the issue. The only way to save it is the US Congress, so anyone wishing to learn more, or US citizens looking to take action, should visit www.savechandra.org, link in the description below, and write your representatives and senators to bring their attention to it, and give it a line item in the budget to keep it going, as is how Hubble is funded. After all, we paid for Chandra, we should use it to its fullest. Losing Chandra would be a huge problem because there isn't a great replacement in store, as the one mission that would have been able to carry on the legacy was cancelled. A downsized version, much less capable, is on the table for ESA, but there are no guarantees for that either. There is another telescope something like this already in orbit, XXM Newton, but it actually functions very differently, and while there is some overlap, it works very differently, but does very good science in its own right. It is no replacement for Chandra, however. Chandra's instrument package, however, is different and features 4 basic instruments: a high-resolution camera, an advanced CCD imaging spectrometer, and high and low energy transmission grating spectrometers. The discoveries made by Chandra are simply stunning and numerous, so here's a selection to show what Chandra can do, and has already discovered. One is in teasing out details in supernova remnants, particularly shockwaves moving through the material that was ejected by the supernova. A number of these were observed, including Cassiopeia A, which is estimated to have exploded sometime around the 17th century. But strangely, the supernova, which should have been visible, wasn't prominently recorded. There are a few somewhat ambiguous observations of stars that have since disappeared, and a record of a daylight star in 1630 that was visible on the date of the birth of Charles II of England, though that wasn't really a sign of luck, given that his father, Charles I, would go on to be executed, and Charles II spent his 20s in exile during the English Civil War, before ending up as a somewhat popular king. What Chandra found with the supernova remnant was the first real data on the object at the center of the remnant, though it's unclear if it's a neutron star or a black hole. Another was the Crab Nebula, the remnant of the supernova of 1054, recorded particularly by Chinese and Japanese astronomers. Here Chandra discovered a ring of material around the central pulsar. A much more recent supernova was SN 1987A, and this supernova was interesting because this supernova is recent, 1987. Chandra recorded enormous shock waves moving through the material ejected in the explosion. With black holes, the first X-ray emissions from the Milky Way's supermassive black hole Sagittarius A star were discovered, and a completely new type of black hole in the galaxy M82 that's intermediate between a stellar mass black hole and a supermassive one. A huge X-ray flare was observed with Sagittarius A star 400 times brighter than usual that seems to have represented either some strange entanglement of magnetic field lines within the material accreting on the black hole, or possibly it might have been the violent death of an asteroid falling in. Perhaps the most bizarre discovery regarding black holes made by Chandra was sound in space of sorts. It's always been rightly noted that there is no sound in space, and science fiction movies and television often get that wrong. And that's true, except when you have material floating in space, such as the material around a black hole. Chandra found X-ray emitting loops within the supermassive black hole's vicinity in the center of the galaxy M87 that are best explained by shock waves and actually sound waves moving through the material. Scientists believe that these are actually the lowest known musical note in the universe, a B-flat, 57 octaves below middle C. You would not hear this note if you were within that material. Other astronomical phenomena observed involved an unusually high amount of gas moving to the center of the Andromeda Galaxy. The first ever observation of X-ray emissions in conjunction with a gamma-ray burst, and the discovery that some of those bursts seem to originate from intense star-forming regions. Also pressure waves seen in areas where galaxies are merging, the confirmation that nearly all main sequence stars emit X-rays, and more dark matter evidence in the form of observations of the behavior of a supercluster collision. For the solar system, it actually saw Titan's shadow blocking X-rays as it passed in front of the Crab Nebula. It also discovered that Jupiter's X-ray emissions come from its poles, but not its powerful auroras. Uranus was also found to be emitting X-rays, but most bizarrely, so was Pluto. And there are also several just plain odd observations that weren't expected. One of these was a pair of objects known as RxJ1856.5-3754 and 3C58 that were thought to be pulsars, but Chandra's data revealed that something was a little off. The results of this observation are contentious still and subject to debate, but these objects may be slightly denser than pulsars and would be the first discovered quark stars, which hover right on the edge of collapsing into black holes, crushing the material in the star into its constituent quarks. Yet another long-shot observation was the chance observation of what might be an exoplanet located in the Whirlpool Galaxy, making it one of only a handful of accidental, serendipitous observations of planets in distant galaxies. And there was much, much more over the course of Chandra's mission. Hopefully Congress acts, and we'll get perhaps as much of a decade more out of this telescope without just turning it off for good while it still works, especially in the face of the fact that there is no comparable replacement ready for Chandra, and when there isn't anything to use to study, then X-ray astronomy itself suffers from a loss of interested scientists going into that field, and one of the most interesting and difficult areas of astronomy will go stagnant. Hopefully that can be avoided. Americans, write your politicians and encourage them to save Chandra. You'll find everything you need to know to do that at www.savechandra.org. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently giving a heads up. Coming up on Event Horizon, I will be interviewing Dr. David Pooley of the Chandra team, who will update us on the cutting-edge current science being done with that venerable telescope. You will be amazed that telescope science has not gotten the attention it deserves. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.